area and circumference. It's pi r squared. So this answer, 25 pi, in some places, like in some textbooks, they might actually want it written this way. This is considered an exact answer. It's 25 pi. So this would be an exact answer. So if I was using that for something else in a different part of a problem, I actually kind of like 25 pi as an answer. However, if we actually want like a real answer, like if I actually want to know what the area is, the square footage is of this circle top, I'd want to actually find an answer. I wouldn't walk into, Home Depot to ask for a tarp that's 25 pi units, like it sounds kind of crazy. So I'd want to be able to convert that over, so we get like 78.5. And that would be inches squared, or sorry, feet squared. Not inches.
All good.
So again, that exact answer, we'll use that today. I don't remember how they say it. They say like do not round or something like that in our homework. Down here, the circumference is 2 times pi times r. Now Erica pointed out you could also do the diameter times pi, but since we know the circumference, we can just double it to find the diameter. It's the same formula. So 10 pi would be our exact answer. So again, if I was using that in another problem, 10 pi would make sense. But then I actually want to do 10 pi to figure out what that is. And in your calculator, you might have to have it tell you the decimal equivalent. So 31.4, I guess I could have known that because it's 3.14. And then this is inches, or sorry, feet again. Why do I want to do inches? All right, why would either of these two measurements come up?
You're making a coaster.
You're making a coaster. So the coaster, what part of it is which? What's that? All right, so if we're talking about a coaster, like if we were putting like a little trim around the edge, it would be that part, the part of like the coaster that actually like keeps your soda from sweating on your like countertop or whatever. That's the covered part, so that would be the big coaster. You're not questioning the size of our coaster?
The coaster. It says largest coaster. So.
All right, rims on a car. I think I heard like so
It's
like
not a car, it's a truck.
John's
So if we picture, hey guys, yeah, we did hit a deer with or not. So the outside edge of the rim would be the circumference. If we actually wanted to cover his rims, and maybe they got a little blood on it, we needed to cover it. Then he's gonna be up today. All right, and the people online have no idea what we're talking about because they weren't here for that part. Yeah, John.
John supposedly hit a deer this morning. We don't know.
Okay.
Still being investigated.
So, Mr. Donahue and I both hit deer like in the same week once, and we like literally never, like we with each of our cars, and no damage on either one. I think his car might have a little bit of a hood issue, but like I hit I stopped for the deer, and then the deer ran into the side of my van, like I did not make the morning workout. And then Mr. Donahue like kind of did that, like I think he bumped the deer and it like fell onto his like the hood of the Fiat, and like you can kind of see the Fiat's a little bit weird, but so we got lucky.
Can't take it. You know what can? John's truck. John's truck can take it.
The Fiat counter certainly sure. All right. So guys. So. All right. So arc length versus sector areas is something I know you guys have learned before, because if you take in geometry, it is something we probably covered in our area chapter. So arc length versus sector area, they kind of use the same piece of information. So picture your slice of pumpkin pie, whatever it happens to be, our arc length versus our sector area. So the arc length comes from, is if I was taking this outside edge. So if you picture like you're gonna put like whipped cream or something around the outside edge, or I'm trying to think of other situations that you need just the outside edge. Oh, maybe you live on a lake that's a completely circular lake. This is how much like lake frontage you have for that part, that's a little section of your land. Whereas sector area is this whole slice. So if I was covering the whole slice with Cool Whip, which is the way I eat my pie, is it's got the whole thing's got to be covered. You shouldn't have to see any pie covered with Cool Whip versus just the little edge. So the arc length, and now arc length and circumference go together. So it's part of the circumference. Whereas sector area goes with the area of a circle because it's part of the whole pie. You know, like so like again talking about the whole thing being covered. So this is the top of that section. And this is always square units because it's area. So again, when we have units like this, we want to make sure that we tell what kind of units they are. So again, feet versus inches, or square feet or square inches, whatever that happens to be. So again, this goes with area. So the chart below here is just trying to show you guys the different formulas that we're going to use today. Now, one of these guys were asking you know, can we just skip this section? And I was actually talking with Mr. Hatfield this morning and asking, he tells me like what he teaches in different sections, and I was like, I guess I didn't quite understand why we had to do this in this section. And he reminded me about the idea that radians actually make these formulas a little bit easier. So we'll talk about that. We'll use radians and degrees for them. We'll kind of do some of both. So, we're going to compare, like, again, a circle. And we'll do circle area. So the whole circle is pi r squared. So the next one's going to be sector area. And I'm going to show it two different ways. I'm going to show it with degrees, and I'm going to show it with radians as well. Okay. So, okay. So, they use x. I'm going to use theta though as well. And so, for sector area, we need to know the measure of that angle of our slice. So again, you've heard this, like when you go to pick out your piece of pie, grandma always says, do you want a big slice or a little slice? You know, like, and then your mom's always like, just a little sliver, and then she keeps telling you make it bigger. And so, you know, or whatever. So the size of your slice of your pie probably, you know, makes sense. So we have to know that. So sector area in terms of degrees is basically we take the circle formula and we kind of use part of it. So this is basically saying this is just a section of the whole circle. And what we're going to use is we're going to use that angle out of 360, and then we're going to multiply it by the area formula.
Do we get a note sheet for this test?
Yeah, so this is definitely, well, part of it. This is the test that you get part of a note sheet for, and then part of it you won't get a note sheet. This would be something you can use a note sheet for. So that's theta over 360. Oh, sorry. Yeah, thank you for, I thought you just couldn't read it, but no, you just couldn't, like you didn't agree with me because you were right. So yeah, thank you. Oh gosh, come back here. All right, let's fix this. It's not times the circumference, it should be times the area formula. Sorry. Thank you for noticing. Sorry, hopefully you're writing pencil.
I don't know.
Well, but this morning I was up to read my textbook for pre-calculus and it was the wrong formula. Okay. All right. It's pi r squared. So what this is it's basically saying out of how much of the whole circle is this area taking up. Now radians, the formula is not as great for this one as it is for arc length. But this one, the sector area, is 1/2 r squared. Whoops, this should be a squared. Times our theta. So it's not like it's like 100 times better, but at the same time, again, the reason for that is because it takes out the 360 because of the fact that we know radians are divided, like to switch it over to degrees, we divide it by 180 and or back and forth. And so that's why the 1/2 comes in, because of 360. So either formula works, it just depends if your radians or degrees. Now, if you actually had to convert between these and then choose which formula to use, it'd be a big pain. So having two is not a bad thing, especially when you have a note card. All right, so again, the next one is circumference. We've already talked about this. So again, the circumference is the distance around, and I will list, or sorry, not A. I will list both formulas. Like I said, Erica had mentioned that you could use the diameter as well. Because the radius is just diameter cut in half. So with this arc length, again, the formulas, one is easier than the other, and this is the one that's really nice with radians. So if we know the radian measure, it makes this arc length a lot better. And again, I'm going to use theta for my arc length instead of x, just because that's what you'll see more often as we like move up in mathematics here. Now they use a cursive L for arc length, and that always looks weird because I always think it looks like a big E. So again, just like we did with our area, we took the x divided by 360, or the theta divided by 360, times 2 pi r, so times the circumference. So this is the time we like radians. The 2 over 360 becomes 1 over 180 pi. So this just becomes theta times r. So again, this is kind of why this is useful, or like why it's helpful, is it's really nice if we have it in radians for that.